Hello, so I'm learning structs and implementation still. Let's create a struct called centimeter. It's going to be a tuple struct. We'll create one called inches. And we need to give each of these a data type. So let's make this one F64, F32. Okay, and we will make an implementation as well. And we will call it inches. And inside that, what we want to do is convert inches to centimeters. Function convert to cm, and we're going to pass in self, and we're going to return centimeters. Now, what we need to do is do let, and we need to say that we need to borrow inches with whatever it contains. Call that inches as well. And we need to set that to the self instance. Next, what we will then do is we will take that and we will then do the multiplication. So we'll return centimeters with a value inside which will be inches, but it's the wrong data type, so we need to do as F64 and then multiplied by 2.54 to convert from inches into centimeters. And when we use this, we will say let we say if we let foot, 1 foot, imperial measurement of 12 inches equal, and then we specify the struct and we give the struct a value. So we'll say 12. Now let's actually use the implementation and we will say println, and we'll pass in we'll actually use the convert to centimeters, but we need to use the convert to centimeters on our variable called foot. And convert to centimeters, no, it's autocomplete, sorry, convert to centimeters. Make sure we put the brackets at the end, it's easy to forget those, or it is for me. And let's run that. I've got a feeling we'll get a debug warning because let's put that in there and then it will tell us to do the old derived debug. Centimeters cannot be formatted, debug, so on line 2 it's telling us to put derived debug, which is nice of it, and we need to do that for the centimeter struct and run it again. And what have we got here? We've got another error. Oh, it's expecting a float, so let's run that again. Clear. And that's not complained, so let's run it. Centimeters, 30. It's actually not, that's not entirely accurate, but it will do for the purposes of this video. Centimeters, 30.48. Now, if you wonder where this has come from, this has actually come from here, which is Rust by example. And I actually found this when I was looking up something to do with derive. What I've been doing is trying to not necessarily memorize, but active recall. I did a video on this on my Python 360 channel if you're interested in. The whole purpose of active recall is to test your understanding, and also I mentioned the Feynman technique, which is where you try and explain things. I probably didn't explain very thoroughly there what I coded, but but here's the original example anyway. So Rust by example and derive, the links up here. You can just search derive in the magnifying glass and you should find, looking up types as well. There you see, derive traits. So one of the key features of what I've just done there actually was using a tuple struct. So more often than not, you'll probably be familiar with actually having a struct where you have the curly braces, but you can have a struct with. If you read the article, you'll actually see. I think it's no. You have to go somewhere deep into the RFC or the developer discussion for Rust, and they actually discuss the official docs, okay. They actually discuss the pros and cons of the struct with the parentheses versus struct with the curly brackets, curly braces. So let's just recap on what we've coded here. We've coded a function. So an implementation can have many functions. If you're coming from Python, consider it as, it's not the same, but as a kind of analogy, it would be class with method inside. That's kind of my crude way of understanding it. So we've got function with self instance, and then what we're doing is we're returning centimeters, which is a struct, and inside that it will have a value. We're putting this value into the struct. This value is calculated based on inches, and inches is what we pass in when we create an instance of this function, and we pass in foot, and foot is equal to 12. So 12.0 goes to foot, foot goes down to here, which then goes into the function, which then becomes self, and then inches equals self, and then we actually do the calculation, and then we return centimeters. And then that's what actually gets printed out here. Well, it actually gets printed in here because we've used derived debug. So yeah, it seems like a very long-winded way of doing it, but obviously this is an example and there's many better real-world applications of this. If you've got any, then yeah, please add some comments in the description, add some comments in the comments, and I'll be back very soon.